power on top, x squared on the bottom. So I've got a higher power on the bottom, and what's happening? It's going towards the x-axis. Okay? So that's the case where you have a higher degree in the denominator, and your horizontal asymptote at y equals 0. Now what if they have the same degree? Okay, in that case you need to look at the leading coefficient in the numerator and the denominator. Okay, now I hate to give you more letters, but I really don't know what else to call this. I usually just call it A over B. Okay, you have y equals A over B. Where A and B are the leading coefficients in the numerator and the denominator.
So in this case, that it would be a 2 over 2 in our problem we've been working?
Well, no, the problem we've been working didn't have the same degree. It had a higher degree in the bottom.
I'm confused.
The leading coefficients are just your coefficients with your highest x power.
Okay, so it has to have the highest x power to be the leading coefficient. That's
But you're only looking at this in the case where you have the same degree.
okay.
If you don't have the same degree, you don't need to look at it.
Okay.
Okay, now let's get back to that problem we were working. Number 5. And now we can figure out where the horizontal asymptote would be. So what is my case here? If I've got 1 over x minus 4. I have a higher degree in the numerator, higher degree in the denominator. They're the same. Higher degree in the denominator. Okay? If I have a higher degree in the denominator, then my asymptote, horizontal asymptote, is 0. Always 0. So you just have to know those rules there for that. For that case.
So why is it a higher degree? Because the numerator is looked at as a degree of 0?
Yes, a constant is degree 0. X minus 4 would be degree 1.
That makes sense.
You think of it as where do you have more x's? It has a higher degree. So you got more x's on the bottom than on the top. The top has 0 x's, the bottom has 1 x. Alright, let's try another one. Oh, this is a good one.
That has an equal degree.
That has an equal degree, okay. But first we've got to find the
Denominator.
Denominator. Or the vertical asymptote. Not the denominator, it's the wrong D word. The domain.
Oh, that's it. You're like, I'm going to bribe you with caffeine.
Okay, so to find my domain, I want to let the denominator equal to 0. Okay, now how do I want to solve this for x? Linear function, so I don't need to factor it. I can just solve by subtracting 4 and dividing by 6. So I get negative 4 over 6, which they will expect you to reduce to negative 2/3. plug in -2/3 on top, you won't get 0. So it only makes the denominator 0, so it is a vertical asymptote. Okay, now what about our horizontal asymptote?
The leading coefficient is higher than the
No,
Or no,
they're
no,
the
no.
same.
I've got the same degree because my highest powers on the top, I've got a 2x, a minus 2x. I think that one will let me write here.
So what do you do when they're the same?
What do I do when they're the same?
-2/6?
Well, I want to get it to let me write here. I don't want
Give me a
There we go. Okay, so I've got 5 minus 2x. So they have the same degree. To find the leading coefficient, what I need to do is look at those terms that have the highest power of x. So on the top, I'm looking at the minus 2x. Basically, you're looking at your coefficients of those x's. Okay? So the leading coefficient on top would be -2. And on bottom, it would be 6. Now, why is the 5 on top not the leading coefficient?
Because it doesn't have a variable. It doesn't have x.
It's not your highest power. Okay? So basically on top, you've got to think of this as being rewritten in the right order, with your x coming first. The leading coefficient doesn't mean it's first, it means it has the highest x power. So I'm trying to write and spell here, which is not evident. So I would have a horizontal asymptote at leading coefficient on top is -2x, and then leading coefficient on the bottom is 6. Okay? That reduces to
-1/3.
-1/3.
And that is your answer?
That is your answer.
Cool.
So what was telling us that there was a horizontal asymptote is that they do have the same degree.
They do have the same degree, yes.
Okay.
Okay, let's look at a couple others for practice. You guys want to look at, you guys want to try number 7 on your own?
Sure.
Try it on your own.
Do you want this on the paper that we'll turn in, or?
You can if you want. Did you guys do another problem already on Monday? can do that or you can just back
So you
down.
have higher degree in the numerator.
Either way, we're gonna take it.
Higher degree at the top. Until it equals right.
Okay, so I don't know what to do once I get here.
Okay? So we're gonna look at those and say neither of those would make the numerator equal to 0. So neither of these can cancel out with the numerator. So they're both gonna be vertical asymptotes. Okay? Alright, so on mine I've got
I think they're exactly the same as it goes for the domain.
some people have different, I think maybe have different numbers on the bottom.
No. I got 3 computers in front of me, and no.
Do you guys all have x squared minus 32? Yeah, they should all be perfect squares though. So you can factor that as the difference of squares. Mine would factor to x plus 6 and x minus 6. So my vertical asymptotes would be at 6 and negative 6.
Now the degree is higher on top, so there is no vertical or no horizontal asymptote.
Correct. The degree is higher on top. I've got degree 3 on top and only degree 2 on the bottom. So we would have no horizontal asymptote.
Which makes sense because if you divide it out, you would be left with just simply x to the first power, which is a linear equation.
Correct. Okay, let's look at number 8. Number 8 is where we're going to see a hole in the graph. Okay, so the domain for this one, if x minus 1 is my denominator, then I cannot have x equal to 1. Okay, because if I put in 1 on the bottom, I would get 1 minus 1 equals 0. Now, normally, that excluded point would be a vertical asymptote. But in this case, x equals 1 would also make the numerator equal to 0.
Oh. That's why I got that wrong.
Okay? It also makes the numerator equal to 0. If you plug in 1, I get 1 squared minus 1 is 0. Okay? So in that case, that's when you have, it is a hole in the graph.
I was wondering how to distinguish that.
So almost always, if you get a point that's excluded and an x value that's excluded, almost always it's a vertical asymptote. It's only in rare cases where if you could plug it in the top and it would also make the top 0. Usually you have this multiple choice question where it's obvious that something different is going on. And here's one where they also mention oblique asymptote. Remember, that just means a Boolean asymptote. Those mean the same thing. I'm not good at picking a word and using it consistently. Alright, now how do we find a slant asymptote if we need to? Like on the next question.
A degree is higher on the top.
Degree is higher on the top.
Or it equals a linear function, basically.
You can't have a slant and a horizontal, so it only happens in the case where you don't have a horizontal asymptote. To find the equation of that slant asymptote, you want to divide the numerator by the denominator. And you want to use what we learned last time, which is synthetic division.
No.
Yes. You guys don't like synthetic division, you just need to practice it more. So you practice it, it gets really easy. Okay? You want to ignore the remainder. So you generally will have a remainder on these. Just drop the remainder. And your quotient will be a linear equation.
How exactly does that work? It seems like it goes against logic if you have a remainder and that you don't involve it in the equation.
What?
How exactly does that work?
The remainder, there not being a remainder just means that the denominator wouldn't cancel out. If the remainder was 0, then it's a factor of the top.
Oh, okay.
So then that factor would appear in the top, and you could just cancel it out.
That makes
So if
sense.
the remainder was 0, that would be a hole in the graph situation.
How do you figure out the degree of the slant?
Hold on, let me finish my sentence here. Ignore the remainder quotient will be a linear equation. No, Joyce, what did you say?
How would you figure out the slant that it would make?
It's determined by that linear equation.
So when you go there?
That gives you the actual equation. Let's try one here.
Yeah, let's do some synthetic division.
Let's do some synthetic division. Alright, you guys want to try an example that I make up, and then we can try our own problem?
Yeah.
Okay. Let's go back to that problem that we did. The problem that I made up at the very beginning.
That one?
This one. Now this is going to have a slant asymptote, right?
Yeah, because you have a higher
Because
degree
you've
on
got
the
a
top.
degree 3 on top and a 2 on the bottom. No, wait, that's not going to work. No, that's not going to work. Cancel that. You can only do synthetic division if it's 2 on top and 1 on the bottom. Let me just make up one here. We're doing our own problem, and then we're going to do number 9 for practice. Okay, so you guys need to do this to turn in. Because I know anything that's not on the homework, you guys are just going to ignore it. Okay, find the slant asymptote. So let's do y equals 3x squared plus 5x plus 4 divided by x plus 5.
So you can only do synthetic division if you have only 2 on the bottom.
Yes.
And
You have to have a linear, you only divide by a linear factor using synthetic division.
okay.
Anything else you'd have to use like the long division, regular long division, like no shortcuts.
No,
Which we didn't talk about.
I've forgotten how to do synthetic division.
Okay, we've forgotten how to do synthetic division. How do we do synthetic division?
Is it going to be multiplied?
I'm sure if you
by
just
negative
started
5?
off, remember it.
Yes, columns first. X squared,
Ah.
x, constant.
Thank you.
Hannah says what goes in my box is
Negative 5.
-5, right? Remember you gotta look at the opposite when you're dividing. You're looking at the 0 of the.
And we're doing the denominator?
Yes. So denominator, the 0 would be -5.
scroll it up a little bit? Thank you.
Okay, and then my coefficients are 3, 5, and 4.
Okay, now I think I can do it.
Okay, make your line. What's my first step?
Drop the number 3.
Bring down the 3. What's my next step?
Multiply it by negative 5.
Negative 5 times 3 is
Negative
negative
15.
15. That goes in the second column. Negative 10. Multiply again. 50. And then add 54. Okay, 54 would be my remainder. Negative 10 would be my constant. 3 is my x term.
So 3x minus 10.
Okay, so just scrap the remainder. We don't even care about that. Really, once you get to your third column, you can just stop because you don't even care. I mean, once you get to your constant on the bottom, you can stop if you're really lazy. Okay, what's my slant asymptote?
Now, if we go to plug that into the graph, so we can look at it, how do we put in that minus 3x minus 10?
I would need to graph the whole. To see if this is a slant asymptote, I need to graph the original function first. You guys want to look at that? See what it looks like?
Yeah, I think she actually has a point there. If you were to graph it, it should come out as a linear function.
Now let's look here. 3x squared plus 5 equals 4. Well, to get the full effect, you need to graph the original function first. Yes.
Why did we use the remainder?
Say what?
Why did we use the remainder in that equation?
I did not use the remainder. I just
Why
ignored
not?
it.
You used it against Tuesday. What's the difference?
We're doing something different now.
So you use it sometimes and not others.
It depends on what you're doing. Yeah.
I know, that's the point I brought up. And she said that if the remainder came out 0, it would be a whole.
In that case, on Tuesday, you wanted the remainder to be 0 because that tells you that it was a 0, that it factored into the top. Okay. Here, you don't want it to factor in the top because then it could just cancel out. So you're actually looking for a remainder that's not 0. Okay. So if my remainder was 0 here, then that would mean that x plus 5 would go into the numerator evenly.
Which would make the whole.
Now, if x plus 5 went into the numerator evenly, I could just cancel it out. No, we don't expect that to happen, so I'm not expecting the remainder to be 0.
I guess I kind of see the linear to that.
You kind of see the linear?
Mm-hmm.
If you zoom it out far enough, you can kind of get the linear effect. So I zoomed out a few times. It's really obvious when you graph the slant asymptote. See, can you guys see the green line? Make that a different color. See the green line?
I think if you zoom out far enough too, you can also it practically goes right into a straight line.
You see that? The slant there?
I couldn't say it into a straight line.
Okay. So the red is my original function, and then the blue is my slant asymptote. Okay. So if you zoom out far enough, you'll see it starts to follow that slant line. And then I've also got a vertical asymptote here.
And you get a hole.
Do I have a hole?
Yeah. See the graph?
See the bent line?
You actually have 2 holes.
You can only you can't have a hole there because the denominator is linear, so it can't have 2 zeros.
So why does the graph result in such an odd shape there then?
Why is it bent like that? It's just squished, basically.
So if you zoom it in, it won't be
If you zoom it
squished.
again, it won't be squished.
Ah, you're right. Okay.
Yeah. See.
That's terminology.
Okay, you guys wanna try number 9?
Yeah.
Yes! You'd love to.
Excitement.
Alright, try number 9.
Now, if you just have an X square, you point that as a 1 and bring that down, right? Mr. B? And then the next one is gonna be a 0 if there's no X.
Exactly.
Oh, wait, wait.
Yeah.
Right?
Mhm.
This is gonna be,
Well, I did the one.
this is here,
Okay.
negative,
Negative.
X minus 1.
and then the negative
Yep.
outside,
Zero plus
this
negative.
one is gonna be a negative 5.
I just take this one.
Negative one
So
plus
then you
one.
add it to it, what do you mean 0 divided by 5?
2 plus 1. Okay. Put your remainders. Right. You need to make sure you put your remainders.
Oh, okay.
I grabbed one.
Oh, did you do using division? You just did it.
I used it.
What's it?
It came up with like.
Alright, I remain it on this now. And
What?
I know since I don't want to remain, I just cross it out. I use it for solution like this one right there.
Okay, oh, so it means.
So
Yeah.
follow that example and do the same.
1x minus 1. Or x minus 1.
How would we write that?
I
Oh, this is
It's just x minus 5. Just write that in.
Yeah.
Okay. So
Okay.
that's my answer.
Mhm.
No, you're fine.
Oh, I got it wrong.
Your number out here is wrong. You wanna see, I use negative 5 because I put 5 in there. So we've got plus 1 and then bottom, you wanna use negative 1.
Oh, I'm using the wrong one, okay.
I'm thinking you're right. Because there is a whole mustache. Because, first off, only these two have a linear line to them.
Right.
And this, it goes up and back down. That's,
We're looking for linear lines, we're not looking for slope.
But your negative 1 is the side, your negative 1.
and
So I knew it was either gonna be B or D.
this one actually has a hole. It goes down and then goes up. There's a hole there.
Right.
This one, it's just a bump. It's not really a
And I
hole.
already knew that my plans applicant was a negative, so I knew I only had the line going in the negative somewhere.
Go to the bottom, this
Really?
negative 1 on
I'm
the
not
slope.
sure.
How do you do
You
that?
just,
Like
it's
that,
just,
that one.
see that slant there?
You see,
If
well,
you
look at
grabbed
mine.
x
Mine's
minus
actually a
1,
positive.
it would follow that line.
My sign asymptote is actually
They're not
a
gonna graph it for you.
Or it could just be an education.
X minus 1 is gonna be right here.
Cause he's looking at me like, yeah.
Yeah, I just have to
Just
imaginary.
imagine it, yeah.
Mine's actually positive, so I don't think the path will walk.
3 down and 1.
Or it could be a negative.
And then number 10 is not a 3 dimensional.
I tried to bluff on that one and you fell.
And then multiply.